Hello friends, in last video we have seen the chemical properties of reactions of this amine. In that we have seen here about 6 reactions like laboratory test, then we have seen 2 reactions of Hoffman, then carbylamine test with nitrous acid, acylation. Okay, these are the different reactions we have covered in last video. Now in this video we will see the reactions of arene diazonium salt. What is mean by diazonium salt? We have seen this diazonium, the stability of this diazonium, aliphatic diazonium, aromatic diazonium. Yes, aromatic diazonium, that was the stable. Okay, diazonium, it contains a compound in which nitrogen triple bond is present, in which one of nitrogen it have a positive charge. Okay, it have a positive charge and it is attached to one of the free anion, means any anion, Cl minus, OH minus, any. Okay, it is called as diazonium, and we are going to see the reactions of these arene diazonium salt or aromatic diazonium salts. These aryl diazonium salts, they shows two types of reaction. The first one, it is displacement of diazo group, means whatever the diazo group present, that will be displaced. Okay, means it will change its position. And another one in which there is a no displacement, or simply we can say it as there is a retention of this diazonium salt, diazonium group. Okay, now first of all we will see the displacement reaction, displacement of diazonium group. See, the diazonium group means N2 plus ion. Okay, this is the group which is present. I will show you how it is represented. N triple bond N. Okay, this is the group in which this nitrogen it have a positive charge. Okay, and any cation like Cl minus, OH minus, which is anion, it forms a bond, ionic bond, therefore it is called as a salt, diazonium salt. Okay, the diazonium group means N2 plus, it is a very good leaving group. Okay, why? Due to the positive charge on one nitrogen atom bonded to the aromatic ring. Now see this, here it is our aromatic ring. Okay, and the aromatic ring which is attached to nitrogen, it have a positive charge. Because of that, it is electron deficient species, it needs electron. Okay, and to attain that electron, it will be a good leaving group. Okay, this is the reason, because of this positive charge. Okay, as a result, the arene diazonium salts, they undergoes nucleophilic substitution reaction, means simply there is a new substitution of this group by another group. Okay, as a result, arene diazonium salts undergo nucleophilic substitution reaction with a variety of nucleophiles. We will see that nucleophile. Table shows the reactions of diazonium salts involving the displacement of diazo group. Now we will see the different reactions for this diazonium. Okay, see, lots of reactions are included in this table. Okay, see, first one, it is called as Sandmeyer reaction. Sandmeyer reaction, and substrate means our diazonium salt. These are the diazonium salts. Okay, aromatic diazonium salts. This is aromatic ring which is attached to the N2 group. Here I have shown. See, here I have shown. Then these are the different reagents which are used for the reaction, and these are the products. Now see carefully. If we have used copper chloride with HCl, the important part, it is a Cl. Okay, Cl minus, it is a nucleophile, and as it is a nucleophile, it shows the nucleophilic substitution reaction. Means, see what happens. The Cl, it will displace this nitrogen group, and that nitrogen N2 diazonium group, it will leave in the form of nitrogen gas. Here arrow must be included. Okay, these are the arrows. Okay, nitrogen, it is evolved in this type of reaction, in which there is a displacement of this that diazo group, displacement of diazo group. Okay, then another one, it is a Gatterman reaction. I think Sandman reaction we have seen. In which chapter, can somebody tell me? Yes, of course. We have seen this in the chapter of halogen derivatives, aromatic halogens for the synthesis purpose. Okay. The next one, it is a Gatterman reaction. Okay, Gatterman reaction. See, this is our arene diazonium salt when it is treated with copper powder with HCl. Okay, see the difference in reagent. Here it is our copper salt and here it is copper powder. Okay, it also forms the halogen derivative of arenes, or simply say it as aromatic halogens. Okay, the important fact we have to note down, this is the displacement of this diazo group in the form of nitrogen, displacement of diazo group. Okay, then another one, it is called as iodoarine formation. Okay, iodoarine formation, here it is shown. Okay, this is only single reaction, iodoarine. For that purpose we use potassium iodide. Okay, then next reaction, it is called as mild reduction. Mild reduction, reduction means addition of hydrogen, addition of hydrogen. Here it is, same happens. See, this is group, this is our diazonium group, it is removed. Okay, and instead of that there is the addition of hydrogen and it forms a benzene. ARH means benzene. Okay, simple benzene. Okay, see the reagent used for this reaction, it is H3PO2, H3PO2. Then another one, same reduction, it is a mild reduction in the presence of alcohol. See, this is the alcohol, that is the ethanol or ethyl alcohol. Here it is also same of happens. See, this is our diazo group, it is reduced, diazo group, it is displaced by the hydrogen. Okay, and that aromatic ring, it get reduced and it forms a benzene, it forms a benzene. Okay, this reaction also we have seen in 11th standard, in 11th standard for the synthesis of benzene. Okay, the next one, see the phenol formation. Here it is shown. For phenol formation we just have to treat this diazonium salt with the water. You can simply say it as a hydrolysis. Okay, in this, see what happens, HOH, H reacts with that Cl and it forms HCl. Okay, and remaining OH, it is attached to the aromatic ring and it forms phenol. This is the phenol. Okay, these are the different reactions in which the diazonium group, it get displaced, diazonium group, it get displaced by using different nucleophiles. These are the different nucleophiles. Okay, and it is called as nucleophilic substitution reactions, nucleophilic substitution reactions. Okay, most of the times the question it is asked, you just give the name of this reaction like Gatterman reaction, Sandmeyer reaction, these are the name reactions. Okay, you have to give these examples. Okay, now these are the just general examples, these are just general example. Okay, for exam purpose question may be asked like this is given, here it is another group, here another group, here it is big group. Okay, and just there is presence of n triple bond n plus Cl minus. Okay, and you have given a reagent like CuCl, first reaction CuCl HCl. Okay, what do you have to do? You don't have to see the other part, means this benzene ring part. Okay, you don't have to see, you just have to replace this diazonium group. Okay, with the Cl only, with the Cl only. Okay, don't see the another part. Okay, for CET purpose, similarly as a NEET purpose, most of the time question it is asked, and because of this aromatic group, it looks big. Therefore, we feel like this is very hard question, tough question. Okay, so don't focus on that. Just focus on this diazonium and this reagent. Reagent also important because reagent changes, this reaction product it is also changes. Similarly, there are also other reactions in which there is a retention of diazonium group. Okay, we will see that also. Okay, but keep in mind the reagent. Keep in mind the reagent. Don't see at the aromatic group, just see at the diazonium group and the reagent given. Okay, now what will be the product? There is a simple displacement of this diazonium by Cl. Simple displacement of this diazonium group with the Cl. Okay, okay, this is our reaction. Okay, next we will see the reaction with the fluoroboric acid. Fluoroboric acid. Okay, HBF4, it is called as fluoroboric acid. Now see, the arene diazonium salts on reaction with fluoroboric acids, they gives precipitate of diazonium fluoroborate. First they gives precipitate of diazonium fluoroborate, and which is on heating it gets decomposed and it yields a fluoroarene. It yields a fluoroarene, means aromatic ring, and to that aromatic ring fluorine it is attached. To that aromatic ring fluorine it gets attached. Okay, fluorine it is very violent reactant. Okay, very violent reactant. For that purpose this reaction it is used, okay, to attach the fluorine with the benzene ring. On the other hand, when it is heated with aqueous sodium nitrate, means that diazonium fluoroborate, when it is heated with aqueous sodium nitrate NaNO2 in presence of copper, it gives a nitroborane. It gives a nitroborane. Okay, means instead of the fluorine it will get a NO2 group. Okay, nitro group, NO2 group. Okay, okay, see the reaction. This is our arene diazonium salt. Okay, it is treated with, it is treated with this fluoroboric acid. Fluoroboric acid. See what happens. See what happens. The BF4 group H plus and BF4 minus, H and Cl, they combine and they forms minus HCl. Okay, and the BF4 group it is attached to the diazonium group. Now if we simply heated it, it get decomposed and the diazonium group it is displaced. Okay, and there is a formation of fluoroarene. Fluoroarene or fluorobenzene also we can say it also. Okay, but aromatic we can take any aromatic group, just I already told you, any aromatic group. Okay, similarly if this diazonium fluoroborate, okay, if it is heated with NaNO2, NaNO2 sodium nitrate in presence of copper, it forms nitroarene or nitrobenzene. In this case, if we have used this as a aromatic as a benzene. Okay, but generally we have to say the aromatic, sorry, nitroarene. Nitroarene. Okay, similarly here also there is a displacement of this nitro group. Okay, displacement of nitro group. Okay, this is the reaction with the fluoroboric acid, aromatic diazonium salts. Very simple reaction. Just you have to replace this diazonium group. Okay, just you have to replace that diazonium group. It is with, it is with fluorine or a nitro group. It is with fluorine or a nitro group. Okay, please try to solve the another examples for CET need purpose. Most of the times this aromatic group it is big group it is given, just I already told you. Okay, don't focus on that, see the reagent only, see the reagent only. Okay, for that purpose prepare one page and note down the reagents and their products, reagents and their product for this diazonium. Okay, it will be easy for you whenever you study the comparatively. Okay, your mind it is set for that, you know the all the types of questions, your mind create that questions. Okay, and it is good, it is called self study. Okay, for that purpose prepare one page and note down the reagent and their products. Okay, now we'll see the another type of reaction. Just we have seen the displacement of diazonium group. Now we'll see the reactions involving retention of this diazonium group, and this type of reaction it is also called as coupling reaction. Okay, it is a coupling reaction, means diazonium group it is does not displaced or it does not undergoes any kind of change in its position. Okay, it does not changes its position, it takes its position, just it happens reaction but a coupling reaction. Okay, we'll see where it is coupling is happening. Now see, the arene diazonium salt when it is treated with certain reactive aromatic compounds. Okay, this is also important condition, our compound it must be reactive aromatic compounds. Okay, such as phenols or aromatic amines, they gives azo compounds. Okay, now this azo it is very important. Okay, azo compounds these are generally used for the synthesis of dyes, synthesis of dyes. We have seen this for carbylamine. Okay, dyes these are used, or dyes these are very colorful compounds. Okay, these azo compounds they have extended conjugated system of double bonds in which two aromatic rings are joined through the azo group. Okay, two aromatic rings get joined by the azo group. See, this is the azo group. Okay, instead of nitrogen nitrogen triple bond. Okay, in diazonium salt. Okay, there is a nitrogen nitrogen double bond and it is called as azo group. Okay, this reaction it is called as azo coupling because at this side I will show you nitrogen nitrogen, here it is aromatic and here it is also aromatic. Okay, now see what happens, aromatic it contains conjugation means alternate double bond single bond, here it is also alternate double bond single bond, here it is also double bond present, therefore there is a lots of conjugation or lots of delocalization in this type of compounds. Okay, azo compounds these are brightly colored. Okay, and are used as a dyes, as I already told you. Okay, these compounds are used as a coloring reagent, are used as a coloring reagent. Okay, their colors are very bright, this is the reason. Okay, this is an example of electrophilic aromatic substitution reaction. Here, the electrophiles are positively charged diazonium ions, and substitution it is usually occurs at the para. See which position? Para position to the ring activating group. For example, we will see one example. So this is our benzene diazonium chloride. Here it is given. This is a benzene diazonium, and this is the chloride. Okay, when it is treated with phenol, see this is the phenol. Okay, in alkaline medium, this is the alkaline medium, it gives para hydroxy azobenzene. Okay, and it is a orange dye, it is a orange dye. We have seen this reaction, we have seen this reaction in the laboratory test, in the laboratory test. See, this is our para hydroxy, sorry, para-hydroxy azobenzene, para-hydroxy azobenzene. See the position, there is a retention of this nitrogen nitrogen bond. Okay, instead of triple bond Here it comes a double bond, and because of that it is called as azo compound. Okay, if it contains positive charge, means triple bond and positive charge, it forms an ionic bond. It is called as diazo. Okay, and if it contains only double bond without any charge, it is called as azo compound. Okay, see what happens? Simply, this is a phenolic group and it is a para activating group. Okay, phenolic OH, it is para activating. Therefore, from this para position, it will attach to this nitrogen. Okay, and it forms this compound. Okay, this is a para hydroxyazobenzene. Para hydroxyazobenzene. See, this is the position of hydroxyl group. It is at the para position of this azo group. Okay, it is at the para position. Okay, we'll see the another reaction of this azo group. See, this is also another reaction. Azo coupling with beta naphthalene NaOH. Beta naphthalene NaOH. It is used for the confirmatory test for this primary aromatic amines. We have seen this test. Benzene diazonium chloride, it reacts with aniline. See, here it is our aniline. Aniline, it is a primary aromatic amine. Okay, when it is treated with benzene diazonium chloride, okay, means with aniline in a mild alkaline medium. See, this is the alkaline medium. Okay, alkaline medium, it is because of this NaOH. Okay, it gives para amino azobenzene. See, this is the azo group. Okay, and to its para position, it is a amino group, para amino azobenzene, and this is a bright yellow compound. Bright yellow. Okay, very yellow color. It is like this. Okay, whatever the color of these azo compounds give, these are very bright colors, very bright color. Okay, and these are used as a coloring agents for the industrial purpose. For the industrial purpose. Now we'll see the next reaction. Just we have seen the two reactions of diazonium salts, in which diazonium group it is displaced as well as retention. Okay, the next reaction with arene sulfonyl chloride. Okay, arene sulfonyl chloride. See, benzene sulfonyl chloride. See, arene means here it is taken benzene. Okay, benzene sulfonyl chloride, it is known as a Hinsberg's reagent. It is known as a Hinsberg's reagent. Okay, and this is used for the reaction purpose. Okay, that reagent, it is used for the reaction purpose. I will show you the reactions now. The first reaction, the ethylamine, here it is shown, it is a primary amine as it contains this NH2 group. It is a primary amine. When it reacts with this benzene sulfonyl chloride, okay, and it forms N-ethyl benzene sulfonyl amine. Okay, see here it is a compound. Okay, in which NH group, it is directly attached to this SO2 group. Okay, N ethyl. See, this is the ethyl. This is benzene sulfonamide. Okay, and it is a amide group. Okay, it is a amide group. Why amide group? Sulfonamide group. Okay, sulfonamide means this is the sulfur group, SO2. Okay, and this is the NH group. Okay, we have seen just amide in which carbylamine test, C double bond O and NH, these are with in conjugation with each other. Okay, similarly here also same happens. The sulfonyl group and amine group, okay, these are in conjugation with each other. Therefore, it is called as sulfonamide. Okay, and now this sulfonamide, it is soluble in alkali. Alkali means in the base. Okay, in the base like KOH, NaOH. Okay, it is soluble. Now see the hydrogen. See here it is shown. The hydrogen attached to the nitrogen. Okay, in sulfonamide, ethanamide, which is a primary amide, it is a strongly acidic in nature. It is strongly acidic nature. Why it is strongly acidic? Because see the difference in electronegativity, it is high. There is a dipole moment, and similarly in conjugation with this there is a sulfur as well as oxygen. Okay, and because of that it will be easily leave. Okay, and if it easily leaves means it produces the H plus form, or we call it as a proton, means it is a strongly acidic in nature. Okay, and because of that it is soluble in alkali. As it is acidic, as it is acidic means it will be soluble in any base. Okay, this is the first reaction. Now we'll see the second reaction, the diethylamine. Okay, just we have seen the aliphatic primary amine. Okay, and it forms this group. Okay, now see the diethylamine, which is a secondary amine, it reacts with benzene sulfonyl chloride and it gives NN diethyl benzyl sulfonamide. Okay, NN diethyl benzene sulfonamide. I will show you reaction, but see whether it will be present in that reaction, in this reaction. Yes, of course not. Again, because of that it shows different property. It shows different property, as here there is a presence of this hydrogen. Because of that it is soluble in alkali. Now in this case, as that amine, it is a secondary amine, diethylamine, no? Okay, it does not contain this hydrogen, and because of that it will not be acidic in nature. We will see what happens. See, this is our secondary amine. Okay, see, this is ethyl group and this is the another ethyl group. Okay, it will attach to that sulfonyl group and it forms NN diethyl, two ethyl groups, diethyl benzyl sulfonamide, NN diethyl benzene sulfonamide. Okay, now it does not possess that hydrogen atom, means it is not acidic in nature. Okay, NN diethyl benzene sulfonamide does not contain that hydrogen atom which is attached to the nitrogen. Hence, it is not acidic and it does not dissolve in alkali. It does not dissolve in alkali. And because of that, this taste, it is differentiating taste. Okay, means we can differentiate the primary and the secondary amine. Okay, this can be separated easily or distinguished. Okay, what you have to done? What you have to done, you have to take just this Hinsberg's reagent. Okay, and in that Hinsberg reagent you have to add our amine. Okay, if it is a primary amine, whatever the compound form, it will be soluble. It will be soluble in any alkali like NaOH or KOH. Okay, if it is a primary, if it is a primary, and if it is a secondary, if it is secondary, if we follow the same procedure, it will does not dissolve in this alkali. It will does not dissolve in alkali. Now this is very important reaction. Why? Because for the CET purpose, for the NEET purpose, most of the time question is asked in the form of A reacts with B and it reacts with, sorry, and it forms C. Okay, and the C compound form, okay, whenever it is treated with the Hinsberg reagent, it shows dissolution. It shows dissolution means this C part, it is a primary amine. And if it gives negative taste for the Hinsberg reagent, okay, or it does not dissolve in the Hinsberg reagent, then what happens? That C part means our product, it is a secondary amine. Okay, in this form, most of the time, the question it is asked for the CET purpose, NEET purpose. Okay, you have to keep in mind this. Okay, this is a differentiating test. Now we will see some electrophilic aromatic substitution in aromatic amines. Okay, as we have seen the aromatic amines, they possess the aromatic ring, and there will be some kind of electrophilic substitution. Means electrophile it will come and it will directly attach to our aromatic ring. Okay, it will directly attach to our aromatic ring. Now we will see that reaction one by one. Amino group, it is a ortho and para directing. Keep in mind, amino group it is ortho and para directing, and a powerful ring activating group, and as a result aromatic amines they readily undergo these electrophilic substitution reactions. Okay, we will see one by one electrophilic substitution reaction. The first one, it is a bromination. Can somebody tell me what is meant by bromination? Yes, very simple. Okay, there is a addition of bromine. Now see what happens. Aniline, when it reacts with the bromine water, Br2. Okay, at a room temperature, it gives a white precipitate of 2,4,6 tribromoaniline. Okay, see the position, ortho position 2, 4, 6, ortho and para position. As this amino group it is ortho and para directing. Because of that, bromine it is attached to all the present ortho positions, two ortho positions and one para position. Okay, very simple electrophilic substitution reaction in which electrophile it will attach to our aromatic ring. Okay, this is our first reaction. Okay, now the next reaction it is a nitration. Okay, can somebody tell me what is meant by nitration? Yes, very good. There is a simple nitro group it is attached to the benzene ring. Okay, see the direct nitration of aniline it yields a mixture of, see, it yields a mixture of ortho, meta and para, all three products, ortho, meta and para nitroanilines. In acidic medium, only in acidic medium, that NH2 group it is protonated to NH3 plus, means ammonium group. Okay, it is ammonium group and it possesses the 4 bonds with the nitrogen, 3 bonds with hydrogen, and this is the fourth, and it possesses a positive charge. It is ammonium. Okay, it is a protonated amino group, which is a meta directing group. Now this is a meta directing group and deactivating group, and because of that, instead of ortho and para position, there is a formation of this meta product also. Okay, hence considerable amount of meta nitroaniline it is also obtained. And because of that we get the mixture of all three kinds of products, means ortho, meta and para products. We will see the reaction. See, this is the aniline. Okay, for the nitro group we use HNO3, concentrated HNO3, in acidic medium concentrated H2SO4. Okay, it produces all the mixture of, this is the para, this is meta and this is ortho. Okay, the major product obtained it is a para. Okay, can somebody tell why this para product is major product? Yes, of course, there is a less steric hindrance because of the position it is far away from this amino and nitro group. Okay, they have very long distance, because of that it is a major product. Okay, and as there is a formation of NH3 plus ammonium group, okay, which is deactivating group, there is a formation of this meta product also. Eh? And it is a large amount, 47%. It is a large amount. Okay, and orthoaniline it is only 2%. It is only 2%, means we get all three products, ortho, meta, para, nitroaniline. and it is in the form of mixture. Okay, this is the nitration reaction. However however to get only para-nitroaniline as our major product, okay, to get only the para-nitroaniline as a major product, we don't have to get a mixture, means ortho, meta, para. If we just have to need a para-nitroaniline, we have to first protect that the amino group. We have to protect this amino group by using the acetylation. Okay, by using the acetylation. Okay, means we will protect that amino group, and because of that, what will happen? It will be it will be never converted into NH3 plus, and because of that, it will never form the meta product, and it will form only a para product. We'll see the reaction. I will tell you one more time. However, to get the para nitroaniline means only para product, pure product. Okay, the NH2 group, it is first protected by acetylation, nitration, then it is carried out, and then that amide it is hydrolyzed. We'll see the reaction, then you will understand. Okay, see, this is our aniline in presence of pyridine. Okay, it is first get protected. It is called acetyl group. Okay, and this acetyl group, it protects that amino group. It protects that amino group. Okay, now it is not a strong activating group as well as deactivating group. It is does not converted into NH3 plus, and because of that, it does not form a deactivating ring group also for that ring. Okay, when it is treated for the nitration, means with concentrated HNO3 and concentrated H2SO4, it forms a para nitro acetanilide. Okay, para nitro acetanilide. Okay, and then by simple hydration we can remove this group also, means protection we will take out, and finally we will get only single product, and which is a para-nitroaniline. Which is a para-nitroaniline, means first we have protected that amino group, and then we have followed the nitration, and then we get very pure product of para-nitroaniline. Okay, very simple reaction. The next, sulfonation. Can somebody tell me sulfonation? Yes, of course, there is a attachment of sulfonyl group. Okay, see, aniline, it reacts with concentrated sulfuric acid. It is a reagent for the sulfonation, and it gives anilinium hydrogen sulfate, and which is on heating with the sulfuric acid, it produces para amino benzene sulfonic acid, and the common name of this compound, it is sulfanilic acid. Sulfanilic acid means at para position, sulfonyl group, it is attached to the aniline. Okay, and this is a major product. Okay, we will see the reaction, then you will understand it. Sorry. See, this is the reaction. See what happens. This is our aniline. It is treated with H2SO4. Okay, see what happens. First it forms anilinium hydrogen sulfate. See here, anilinium hydrogen sulfate. Now see what happens. This amino group, it get protected. Okay, and then there is a sulfonation at the para position. Okay, and after some time that group get removed, and it forms a zwitter ion. See, this is also important product. Okay, this forms a zwitter ion. Now see why it is called zwitter ion. Okay, actually, see here it is shown. Okay, means this sulfonilic acid sulfonilic acid, in which amino group, which is para position to this sulfonic acidic group. Okay, as this is a basic group and this is the acidic group. Okay, these are highly reactive, as we all know. So what happens, the hydrogen atom, see, this is the hydrogen atom. Okay, it changes its position from this side to this side. See here it is on. Okay, these are the three hydrogen, means it contains one extra hydrogen which is of this sulfonyl group SO3H. Okay, and now it possesses two charge on the same compound. Which two charge? Positive charge as well as the negative charge, and because of that it is called as a zwitter ion. It is called as zwitter ion. This zwitter ion also important product, as we have seen, just it contains both acidic as well as basic group. Okay, for industrial purpose it is the most important compound. Okay, for the variety of reactions, by using this compound you can see the variety of reactions. See, the sulfonylic acid exists as a salt. Okay, and that salt it is called as a zwitter ion, just I told you, and it is a dipolar ion. Okay, it is produced by the reaction between the acidic group and the basic group present in the same molecule. This is the basic group and this is the acidic group. Okay, see, I will tell you one more time. This is aniline. When it is treated with H2SO4, first it forms anilinium hydrogen sulfate, anilinium hydrogen sulfate, and then after it forms a para product. Okay, para sulfonyl aniline. Okay, acid, and it is a sulfonylic acid. It is a common name. It is a common name. You see here it is given para amino benzene sulfonic acid or para amino aniline. We can also say, sorry, para sulfonylic aniline. It is also another name. Okay, and the common name it is a sulfonylic acid, as it contains both sulfyl as well as amine group. Okay, and one group it is acidic, another group it is basic, and because of that it forms a zwitter ion which possess both positive as well as negative charge. Okay, so these are the reactions, different reactions of amine. For this we will stop here. Now keep in mind, please try to prepare a chart. As I already told you how to prepare chart, we have to write reagent at the center. Okay, if we have to synthesize this, we have to give arrow like this. Okay, and these are arrows coming from the different reagents. Okay, these are different catalysts. Then you will recall this reaction. Most of the reactions these will be on single page, in only single chart. In this way you will understand the complete, you will understand the complete reactions, means synthesis reactions. Okay, means how to synthesize. Similarly, you can also prepare the chart in which the reactions or chemical reaction in which you just have to write a, for example, amino group. Okay, and whatever reaction it gives with different reagents, just write like this. In only single chart you will write all these reaction, and by watching this, by comparatively watching this, you will understand all the reactions. Okay, this is the only way, this is the only way to study the organic reactions. Okay, organic reactions, these are very volatile. This looks easy, but these are very volatile. Okay, so keep in mind, please prepare this type of chart. Okay, and then it will be easy for you for your regular study. Now for today we'll stop here, and here our chapter it is finished. In next video we will start our next chapter. Thank you very much.